Hi, welcome once again to Jody Productions video. Special thank you for those who are joining me for the first time, and as always, thank you for those who are returning to my YouTube channel. Today's video focuses on Unit 3 General Maths, Area Study 1 Data Analysis, looking at data transformations, and the skill is the Reciprocal Y Transformation. So let's jump into it. So reciprocal Y transformations. The Y reciprocal transformation involves compressing Y values that are greater than 1 while stretching Y values that are less than 1. Values close to 1 are compressed or stretched less than numbers that are further away, and the X values remain the same. So let's look at this visually. On this graph, we can see that the Y values are moving to make a reciprocal relationship, that is a curve from bottom left to top right, into a linear relationship. The values closest to 1 are changing least, and the values furthest from 1 are compressing and stretching the most. So the lower Y values are stretching and the larger Y values are compressing. So our example for today, let's consider the following sample data that represents the spiciness, and I couldn't find a really appropriate heat unit for spiciness, so I've just called it heat unit, of a curry dish which has an amount of yogurt added to it in spoonfuls. So if you imagine a really hot curry dish, and the more you add yogurt to it in spoonfuls, the less the spiciness is. So our data is represented in this table. So we have on the first column, yogurt in spoonfuls, and on the second column, we've got spiciness in heat units. And you can see that the more spoonfuls of yogurt, the less the spiciness of the curry dish. So our task for this particular set of data, number 1 is to enter this data into the TI Inspire CAS calculator. Task number 2 is to perform a linear regression and calculate the following quantities. Task number 3 is to describe the relationship between the two variables. Task number 4 is to determine the least squares regression line. Task number 5 is to generate a scatter plot using a TI Inspire CAS calculator. Task number 6 is to generate a residual plot, also using a TI Inspire CAS calculator. And finally, task number 7 is to perform a residual analysis. So let's now enter this data into our TI Inspire CAS calculator and perform these 7 tasks. Let's open a list and spreadsheet. In the first column, we put the heading of spoons. Second column, we put the heading of spiciness, and we fill the data. We now go to a stats calculation, format A equals bx. The X variable is the spoons and the Y variable is the spice. And there's our summary for the A, B, R, and R squared for our original data. We now graph that. On the vertical axes, we have spice, and on the horizontal axes, we have spoons. There's our nice curved graph. We can add a trend line, analyze regression of the form A plus bx. There's our trend line, our least squares regression line. We also go to the menu and add in an analysis of the residuals and show the plot. So there's our residual analysis as well. Task number 2 was to perform a linear regression. So our summary from our linear regression is as follows. The y-intercept has a value of 49.068. The gradient has a value of negative 5.868. The Pearson's correlation coefficient, that is the R value, it has a value of negative 0.697. And the coefficient of determination, that is the R squared value, has a value of 0.485. Task number 3 was to describe the relationship between the two variables. And from our visual here, you can see that the strength is moderate. That is a Pearson's correlation coefficient of negative 0.697 puts this association in the moderate region. Its direction is negative because it's got a negative value for the Pearson's correlation coefficient. And the form, well, from the graph we just looked at with a scatter plot, it appears to be non-linear. It looks to be curved. Task number 4 was to determine the least squares regression line. So from the linear regression, we found the equation to be spiciness in heat units is equal to 49.068, take away 5.868 times the yogurt in spoonfuls. Let's look at these visually. Task number 5, let's generate a scatter plot. So you can see here that our curve starts at the top left and falls down to the bottom right. Task number 6 was to generate a residual plot, and this has got a nice big curve in it. So task 7 was to perform a residual analysis. So the residual plot displays a clear pattern. It looks almost like a smiling face. The residuals are clearly positive, that is above the x-axis, then negative, then positive again. And as I mentioned, that's much like a smiley face. This plot does not support the assumption of a linear relationship between the variables. It may be possible to linearize the data by applying a transformation to one of the two variables. So let's now do this. Let's take the reciprocal Y transformation. So we're going to repeat this activity using the reciprocal of y, that is 1 over spiciness transformation. So the table in front of you shows the yogurt in spoonfuls, the spiciness in heat, and also the 1 over spiciness, that is the reciprocal. We wish now to undertake the 7 tasks that we did previously with the original data. That is, number 1, enter the data in the TI Nspire CAS calculator. Number 2, perform a linear regression to determine the following quantities. Number 3, describe the relationship between the two variables. Task number 4, determine the least squares regression line. Task number 5, generate a scatter plot using the TI Nspire CAS calculator. Task number 6, generate a residual plot, also using the TI Nspire CAS calculator. And finally, task number 7, perform a residual analysis. Let's now use our TI Nspire to undertake these 7 tasks. We go to listen spreadsheet, we enter in the value for spoons, we then enter in the value for spice, and now we want to do the reciprocal of spice. And to do that, we simply equals spice to the power of -1. It's a quick way of doing a reciprocal, and our data points are added into the column. We go to menu, stats calculation, linear regression, a plus bx. Our x variable will be spoons, and our y variable will now be the reciprocal of spice. And there's our linear regression for that new transformed data with the a, b, r squared, and r values. Let's plot that. On the vertical axes, we now have the reciprocal of spice. On the horizontal axes, we now have spoons. We can add, through the analyze, we can add a regression equation, a plus bx format. There we have a nice straight line. We can go to menu, analyze, and add a residual plot. And that shows us that varying residual plot. Task number 2 was to perform a linear regression. So the summary for the transformed data is as follows. The y-intercept was found to be 0.0106. The gradient was found to be 0.0199. The Pearson's correlation coefficient, that is the R value, is 0.9998, nearly a perfect correlation. And the coefficient of determination, that is the R squared value, is 0.9996. Task number 3 was to describe the relationship between the two variables. So with this new transformed y reciprocal relationship, we find that a Pearson's correlation value R of 0.9998 clearly demonstrates a strong and positive association between the two variables, and the form is also from our scatter plot linear. Task number 4 was to determine the least squared regression line. So now that we've undertaken a reciprocal of the y variable, our least squares regression line is as follows. 1 on spiciness with heat units is equal to 0.0106 plus 0.0199 times the amount of yogurt in spoonfuls. Now let's look at this visually. Task number 5 was to generate the scatter plot. We can see this now transformed data is very straight indeed. Task number 6 was to generate a residual plot. Task number 7 was to perform a residual analysis. So first of all, we can see the residual plot displays approximately equal numbers of points randomly scattered above and below the horizontal axes. There's no clear pattern displayed. That is, it's not a smiley face or a frowny face. The points are varying above and below the x-axis consistently. This plot supports the assumption of a linear relationship between the variables. This is the correct transformation for this particular set of data. Finally, let's make a conclusion comparing our original data to our newly transformed data. So here's our original data with our linear regression equation and our scatter plot and our residual plot. The original data had a moderate R value of -0.697. Its R squared value was 0.485. We can conclude that the original data probably have a non-linear relationship. The residual plot does not support the assumption of linearity. Transformation of the data may be required. And it's worth noting, a least squares regression line should not be fitted to data that is not linear, as any interpretations or predictions will not be accurate. Let's now look at the transformed data. After undertaking a reciprocal Y transformation, we get our new least squares regression line, which states the 1 on spiciness in heat units is equal to 0.0106 plus 0.0199 times the amount of yogurt in spoonfuls. And you can see now our new scatter plot and our new residual plot. Analyzing this, we can see that our original R value of -0.697 has been greatly improved to a new value of 0.9998. We can also see that our original R squared value of 0.485 has also been greatly improved to a new value of 0.9996. So the reciprocal Y transformation has improved the original R and R squared values. The reciprocal Y transformation has linearized the data. This is the correct transformation for this particular set of data. 1 on spiciness using heat units equals 0.0106 plus 0.0199 multiplied by the amount of yogurt in spoonfuls is the best relationship available for these two variables.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.